All right. Once again, can you hear me all right?
Yes, we can. We can. Great.
Okay, great. Yeah, thanks again. I really appreciate the opportunity that Georgia Tech is hosting this meeting and inviting me to this meeting. I can share that it's their persistent effort, despite all the disruption that NIOSH has been experiencing. Here we are today. I'm really excited to be here. Um, I can share also at the beginning that when I received the meeting invite about the date, confirm the date and the time, I saw the 2 hours window for this meeting. My reaction was, wow, this is exactly what we need now. Because more and more often in recent time that we are only having short communications and in lack of this type of long discussion, open discussion to come together, find solutions. You are all aware, perhaps not so much in our particular field, but in the general public health field, there has been increasing number of misinformation and disinformation that really impact people's health. And part of that may be attributed to the lack of communication and open dialogue. So for that, I really appreciate every one of you for taking time out of your busy schedule to join this meeting. I'm very optimistic that our sharing and discussion today will end up improving the health of the workers in this industry. So without further ado, let me begin with this presentation. So for the target audience of today's meeting, I guess I don't need to repeat a lot of this background. You are all aware of the issue that the growing business in this industry and comparing to natural stones like marble and granite, some early engineering stones really have very high content of silica that really lead to high exposure. And they come from various companies, brand names, manufacturers, made in various countries, such as Israel, Spain, Canada, USA, and many other countries now. So it's not a surprise that we first noticed the outbreak of silicosis in this industry reported out of Israel and then Spain. And in the US, the first case was reported in 2014. Earlier, Jenny showed the map tracking of all the cases. I'm sure that is much thorough tracking. So here I just listed some recent reports I have been following. You can see in US, we had 18 cases, including 2 fatalities reported in 2019. And in 2023, we have another larger cluster reported from California, including 10 fatalities, unfortunately. In the US, we didn't have a very extensive medical surveillance in this industry, but some alarming report out of Australia, as you can see in this map, that they had conducted a relatively large-scale medical surveillance in the industry and consistently found that over 20% of the workers screened were diagnosed with silicosis. That is really alarming. So what we have been doing in NIOSH, I just want to present in this meeting in a way that how we came along in NIOSH from our research tackling this problem. Shortly after the first case reported in the US reported in 2014, we had a HHE request. We did this health hazard evaluation in a relatively large fabricator shop. And the key finding was that for the workers using handheld grinders with a traditional water spray wetting method, they had the highest exposure. You can see the number here highlighted, about 121 microgram per cubic meter. At that time, the OSHA's PEL has not been updated yet, but this was still higher than the then PEL. Of course, more than double the current PEL. And we also found that workers in other tasks, such as operating machines remotely or using handheld polishers with traditional water sprays, their exposures at that time were below the OSHA PEL. So we try to focus on these 2 tasks even though the polishers at that time, the exposure were below the PEL, they were still close or relatively high compared to other remotely controlled the task that only work with remote control machines. So it's not a total surprise that these workers had higher exposure because you can see their task is close to their breathing zone. So whatever they are working on, the emission from the tool hitting the stone slab may readily expose to their breathing zone. So in NIOSH, we did some additional in-depth field surveys. One question we want to answer at that time was whether working with those engineered stones that had higher silica content can really lead to higher exposure. Intuitively, the answer is yes, but we want to have real samples from the field to demonstrate that. So we designed these short-term task-based sampling for both grinding and polishing tasks. So these samples were taken between 20 minutes to 2 hours. We try to focus on the task when they were working on one type of stone, but that's not always possible because their pace was really fast. So they changed different stones during that sampling window. But we still want at least 20 minutes sampling so that we can collect a quantifiable amount of crystalline silica. So here are the results. As you can see, indeed, when they were working solely on the quartz stone, their exposures was so much higher than the OSHA PEL, which is 50, right? And while they were working on, in the sampling period, they were working on a mixed type of stone, meaning part of the time they were working on granite, part of the time they were working on quartz stone. Their exposure was significantly lower, but still, all of these results were either close or much higher than the PEL level. Obviously, we once again saw the higher exposure from the grinding task. You can see this level, and even when they were working on a mixed type of stone. So now let's move on to what we have been studying on engineering controls. For all the engineers and the industrial hygienists, we have our own toolbox, right? So we come to our toolbox to find out to pick up the controls and see how they work. For dust emission, two most used controls were local exhaust ventilation and the wet method. So the first idea most people thought was, why not combining them? Let's use both of the controls, see how they work together to control the dust. In hope that 1 + 1 either equal to 2 or better, larger than 2, right? So Dr. Johnson and Dr. Phillips from the University of Oklahoma, they were pioneering in this research. You can see on the left and the middle section of this slide, they published these 2 papers studying the combined control from a wet method and local exhaust ventilation for a variety of different tools. The results, surprisingly, was a little mixed. For some tools, they did find the combined effect, control effectiveness was better. But in many tools, the combined results were even poorer than just one control alone. That is because actually when we thought again about this approach of combining the 2 engineering controls, is that local exhaust ventilation in the handheld tools, especially if they incorporate into the handheld tools, they may interfere with the operation of the wet method. When we want to have the wet method effective, we want the water delivered really close to the working area where the tool hit the stone, right? So that it can wet the area effectively. Similarly, for local exhaust ventilation, we want the hood or the ducts pickup area to be really close to the same area. And the unintended consequence was that the local exhaust ventilation, when it was really close there, it either deflect the water, or even worse, it suck up all the water. In one of the study in the middle section that I actually work with Dr. Johnson on this experiment. We used a pre-separator for a dust collector that provided the local exhaust ventilation. And after a short period of running for some tools, the pre-separator was full of water. So even before we learned the results, we suspected it's not going to work really well. So on the right side, this picture demonstrates another type of local exhaust ventilation. You can see the dust collector was mounted on the ceiling. So it provided these arms that can be moved around to provide a local exhaust ventilation near a stationary operation. But you can see one hazard that it may bring is that when worker is dragging this arm along their process, they may bring another hazard that they only have one hand holding the power tool. That is not desirable. And for all of us working on engineering control, we know that the main drawback for engineering control is it works as long as people use them. So if we want to ask the workers to drag this arm all along their process, the chances is high that they may not use it all the time. So we came back to the drawing board. We noticed from the field there were two main wetting methods. One is shown on the left side. You can see it's the water is delivered from a gooseneck type of nozzle. The water spray is is pointing to the edge of the grinding wheel, and we call it a spray nozzle. And the right side picture shows another wetting method we call the central water feed, where the water came from a small tube on top of the handle of the grinding tool and coming out from the center of the shaft. There are about 3 small, very tiny holes that water came out from, and they try to deliver the water relatively uniformly along the grinding cup. So we did some surveys, the field surveys about worker exposure using either tool. The results came back that both of them were poorly effective in terms of reducing worker exposure. At first, this was a puzzle for us, and we were asked. I actually received inquiries from employers, from a consultant, an industrial hygienist from the field. They were asking, our shop really operate, very wet conditions. We use a lot of water, and the floor is clean with a lot of water as well. But how come our worker exposure was still high? After some observation from field, we think we perhaps find the possible reason. I will use a few videos to demonstrate that. The first is about the water spray wetting method. You can see from this video, it's pretty obvious, right? I know I perhaps cherry-picked this video. Not all the time that the workers neglected where the water was delivering, but for some tasks, perhaps they were really paying attention to the sophisticated surface, the edge they were working on. They may not have the highest attention on where the water was delivering. And a lot of times the water shoot to the ground directly without wetting the surface and as it's designed to. So the end result is that it may have a short period during this operation that the surface was dry, so it ended up with some dry operation. Same observation happened for the central water feed approach. As you can see, actually before we start, I can point out that the relatively bright area on the surface, you can tell they were dried, and relatively darker area here, they were wet. So you can see along the video, the dry dust formation from the operation. And you can see the worker actually paused a second to intentionally wet the surface. And then still, you can see the dry dust formation and the area constantly get dried again. This is because the 3 tiny holes for the central water feed, they really just so restrictive. They cannot deliver enough water to constantly wet the surface. And the fast spinning grinding wheel works almost like a fan that quickly dry the surface with limited amount of water there. So again, it resulted in partial dry operation, even we know we reuse the water and we provided the water throughout the process. So our immediate thought was, if these 2 methods were not effectively wetting the surface, what about we provide a effective wetting and see whether that can suppress the dust enough to have the worker exposure below the PEL. So we came up with this sheet water wetting method. It's basically just have a water source outside of the tool. We know that those incorporated on the tool seems to have trouble. So let's see, we provide additional water out of the tool to constantly wet the surface. We know for sure we are wetting the surface continuously and effectively. Let's see how it works. So in this case, you can see it's basically just a water hose on the opposite side of the working area and constantly feed water toward the edge. The purpose is that once that is constantly wetting the working area, second is that it continuously flush away the sludge or dust settled in the area, which would otherwise be there without this constantly sheet water wetting method, right? And then we prevent them from being dried and reaerosolized later. So you can see in this case, we have the surface constantly wet. And you can another point I want to make is that we try to the reason we didn't feed this water hose directly right at the edge was that we try to have this sheet formation so that it has a relatively gentle coverage of the surface. The purpose is that we don't want to aggressive collide between the water and the grinding disc, because you can imagine it will create a big splash. And that may bring a lot of the mist and a lot of mist that may contain silica dust that it captured. So these, if there is a strong collision between the water and the spinning disc, it may really splash these mist closer to the worker's breathing zone. And even they are not in the breathing zone, they kind of splash and aerosolize those in the area and become airborne dust later. So that is a kind of another point we want to point out for the sheet water wetting method. So the results were really good, that we found that for workers' exposure using this added sheet water wetting method, their exposure reduced below the PEL level. All the results comparing the previous 2 wetting methods and this new sheet water wetting methods can be found in this NIOSH report. Of course, you can have multiple ways of delivering a similar type of wetting method. This is the study conducted by Dr. Johnson's group, and they simply use a PVC pipe with one end capped and another end connected to a garden hose. And they drilled some 1/4-inch holes along the PVC pipe so that they can have this pipe cover a larger area of the slab. Of course, you can, based on your need, to adjust the length of the PVC pipe, maybe 2 to 3 feet, that workers can easily carry around. So in NIOSH, our research mainly to try to find what is feasible, what is working. I'm fully convinced from my experience that most of the time, people in the industry, once they learn the direction, and they always come up with better design, better approach. So I just want to throw this call to action there. So people in the industry, in the field, I'm sure you can come up with different ingenious ways of delivering similar sheet water wetting method. So we didn't actually give up the local exhaust ventilation type of control, although we learned that if we definitely will want to keep the wetting method, right? So the untold local exhaust ventilation may not be ideal. So what about other type of local exhaust ventilation? For example, the concept of containment and isolation, similar to a pent booth. So we modified a pent booth by modifying the dust collector, and these metal filters can collect moisture, sludge, and so on. So we implemented this with a partner and to test how it works. The design consideration is similar to a pent booth that we have about 100 feet per minute airflow velocity toward the dust collector. And we tested the worker exposure with and without the presence of this dust collector in a kind of painting booth type of control, right? The results was really good as well. We found that worker exposure was reduced about 80%. Again, as I mentioned earlier, one thing I always found is that once we found a direction, a feasibility of our approach, our partners in the industry always come with even better solutions. This is another example. Once we found that this 100 feet per minute flow can help capture the dust significantly. So one of our partners identified another similar dust extractor. Instead, it used a water curtain to capture the dust and mist first, and then behind the water curtain, there were 2 layers of air filters to capture smaller and remaining particulates. Another difference from the previous slide about the isolation and the containment approach is that it had the hooded area of this dust collector is relatively smaller, so it has a more open approach. So it not only work as a local exhaust ventilation when the work was conducted close or inside the hooded area, it also works as an air cleaner to constantly clean air in the surrounding area. So we can imagine for the workers' exposure, they have 2 main contributing sources. One is from their own task when they are actively conducting their task. Another is that when they were taking a measurement, moving the slab, or setting up their tools, or simply take a short break in the area, they were breathing the background air. So the silica concentration in the background air also contributed to their exposure. By having these dust extractors serve as an air cleaner that constantly clean the background air, they can reduce their exposure in terms of 8 hours time-weighted average, right? For this particular case, we work with partner for several back and forth scenarios. They didn't get it right in the first try. As you can see here, list all the results. It's a little busy, but I will walk you through with this. First, the baseline setting was when they didn't have these devices implemented. And the setting 1 was when they had multiple units implemented in the grinding and the polishing area, but they didn't have one designated unit for the grinding process. We learned earlier that the grinding task is actually generating the highest amount of dust. So obviously that was not ideal. It's reflected in the results. You can see the setting 1, the exposure was still relatively high. And we corrected that. We modified the setting by designating one dust extractor for the grinding process, you can see here. And then they can, once they finish, they move the card to the subsequent polishing booth, or polishing dust extractor. And you can see in the setting 2 and setting 3, the reservoir dust was really reduced, right, compared to baseline setting 1. And in terms of respirable crystalline silica, they were even reduced to below the PL level now with this control. And the major difference between setting 2 and setting 3, you can see that the respirable dust level were similar for grinding, but the respirable crystalline silica was much lower for setting 3. That was attributed to the much lower silica content in the when we visit to evaluate the setting 3. At that time, the shop already changed to mostly work with engineered stone, the newer engineered stone that came to the market with much lower silica content, which we'll cover next. So we talked about all these two engineering controls that we demonstrated their effectiveness in the field. For the comparison of the newer engineered stones, we found the laboratory study may be more ideal to do this investigation. So we came back to the lab. We have a testing system as shown in this schematic. We tested 4 different stones, the natural granite, the older crystalline silica, older engineered stone with crystalline silica in resin, and the newer formula or newer recipe with much reduced silica content. It's stone B, we call it here. And stone C is a recycled glass. It's an engineered stone. It's also engineered stone, but it's very different than the engineered or artificial stone we talked the most with associated with higher exposure. These stone is made of recycled glass in cement, so they only have a trace amount of crystalline silica. We want to evaluate them, compare them in this laboratory setting. In this tool testing chamber, we have an air handling unit to drive the flow through the system. And you can see on the far left side, it has a HEPA filter and a pre-filter section that filter out all the room air dust. Then we know later whatever we sampled from the duct were all from the task conducted in the tool testing chamber. This system was designed according to a European standard to evaluate the generation rate of airborne contaminants. So the results, the absolute value of the results here was not for exposure assessment. It's for comparing how the dust generated from different processes. Here we have different tools, different samplers to take samples and compare their results. The first set of results were from the direct reading instruments about the particle size distribution. We learned that even there are different stones, their particle size distribution were very similar. As you can see on the 2 figures, in terms of number-based distribution, they all had a peak around 2 to 2.3 micrometer. And in terms of mass-based size distribution, they all had a peak around 8 micrometer. With this information, and also the respirable dust sampler, we can obtain the silica content in the respirable dust fraction. Here are the results. You can see the main target we want to see is stone B, how it compared to the granite and the older engineered stone in resin. So we found that indeed the older engineered stone A, still had highest crystalline silica content, followed by granite, and then stone B. Obviously, stone C has trace amount of crystalline silica, so it shows almost non-detectable here. Another interesting finding is that the bulk dust and the respirable dust, they had a very similar amount of crystalline silica content. This perhaps is a useful information for exposure assessment, not for compliance purpose, but for evaluation of engineering controls and evaluation of workplace practices. Instead of taking all the respirable crystalline silica analysis for all the samples, maybe by assessing the respirable dust and then assume the bulk dust, the silica content in the bulk dust can be a good estimation about this actual silica exposure. So with the information of particle size distribution, the residual dust, and the silica content in the residual dust, we come up with a new term. We call it a normalized generation rate. It's defined as the mass of airborne contaminant generated per unit volume removed from stone, so that we can really have apple-to-apple comparison among the 4 types of stones we studied here. You can see in terms of residual dust, as shown in the previous distribution data, right? Even they have the similar shape. The granite has the highest residual dust generation, and the 3 engineered stones have very similar amount of generation rate for residual dust. Of course, they have different residual crystalline silica content that leads to different generation rate for the RCS. As you can see here, stone A has, not surprising, they had the highest generation rate, and followed by granite, and then the new engineered stone with lower silica content. Of course, stone C has no crystalline silica. We also had a cascade impactor, the Moody, to collect particles of different sizes and analyze the generation rate for different sizes in terms of crystalline silica. And the interesting finding here is that they all had the peak of generation rate for RCS around 3 to 6 micrometer. This may be valuable information when we design future engineer control solutions. We may want to target particles in this size range. This perhaps give you the best results by considering all the design features. So we mostly talked about engineering control, and in the last laboratory study, perhaps it's a little bit more about substitution, elimination. So I just want to spend a few minutes about how the engineering control fall into the overall control strategy. Many of you may be familiar with this concept of hierarchy of control, from elimination, substitution, engineering control, admin control, and finally PPE. We learned from the laboratory study that those silica content in different types of stones really reflect into in their exposure. So in terms of elimination and substitution, of course, we recommend verify the crystalline silica content in the stones, and when possible, choose those products with little or no crystalline silica that can really help reduce the exposure level. And of course, whenever using a new stone products, we want to be mindful about the potential new or even greater hazard that it may brought into, so that perhaps worth some further investigation. And we talk mostly about engineering controls. The isolation and containment approach is still a valid one, although we later invest more about the local exhaust ventilation type of control, right? Of course, we learned earlier, definitely avoid dry operation, try to use the effective wetting methods, and make the wetting method as effective as possible. And we didn't talk enough about this, about the third bullet here, about improved design of the fabrication process. Most of shops, they have for part of the fabrication process conducted on those remotely operated machines, and only a small portion later in the manual operation. If there can be improvement in the fabrication process, it doesn't matter, it's designed to make it less amount of work for the manual operation, or improve the precision of those machine operations so that you leave very little for the manual operation. That can go a long way to reduce worker exposure, so they don't have much to grind or polish later, right? We talk mostly about the effective wetting and the dust extractor type of local exhaust ventilation, so I won't repeat too much here. And we didn't talk more about the overall ventilation in the indoor space. This definitely can help reduce exposure. As explained earlier, those dust extractors, they not only serve as local exhaust ventilation, they also serve as air cleaner to continuously clean up the background air. So we have some results actually to back up this recommendation. As you can see on the left side is the same site as we explained earlier. So before they had ventilation setting, their area samples were having the RCS concentration at this level. Once they implemented the mechanical building ventilation and those dust extractors, here I explain these dust extractors as partial LEV because, as mentioned earlier, at the beginning, they didn't take full advantage of those dust extractors, right? So they were, there was not one designated for the grinding process. That's why they had a little higher exposure, higher RCS concentration in the background at that time. Once they had improved into the setting 2 and setting 3 with a designated unit for the grinding process, their background concentration was really reduced to this level. And site 2 is another shop which is much smaller. They didn't have mechanical ventilation for the building. So first we evaluated, they did have a dust extractor similar to the one shown earlier. When they partially implement that, in this case, the partial implementation is that they only operate the dust extractor when they had a active task, grinding task in that local exhaust ventilation. Once they finish that task, they turn off. So it didn't serve as the air cleaning purpose. So you can see when they only have the partial LEV function, so the background air concentration is this level, and once they implemented the approach to let it run continuously, their exposure were below reduced to this level. Both these two bars were conducted when in winter that they didn't have any additional ventilation. And in a separator survey in spring, that we found that when they were able to open the door, open the fabrication shop's gate to bring in natural ventilation, their background concentration reduced to this level. So definitely enhancing general ventilation can lead to lower exposure. And of course, we learned earlier that, right, all these engineering controls need to be effectively implemented. That comes to the admin control, where we can train the workers. It's important to train the workers to effectively use these engineering controls. Of course, it would be even more important to train them to raise awareness about the general risk of RCS exposure. So a lot of workers, I'm sure they can come up with their own practical solutions that help reduce the exposure as well. For that, perhaps develop a system or schedule to evaluate the effectiveness of controls and equipment would be helpful. And housekeeping, you can see this picture. I show that in one of the partner sites, they implement these wet sweeping machines, wet scrubbers. They constantly clean up the area so that we don't give those residue a chance to evaporate and re-aerosolize later. We didn't mention a lot earlier about wet operation, about the water quality of wet operation. So that is an important one too, especially for handheld tools. It's ideal to use tap water so that you don't have the growing bacteria in the recycled water for the manual operation. So in terms of the installation, it's a kind of a mixed between admin control or engineering control. It's similar to the improved fabrication process as well, right? Let's try to do more in the shop, less in the field. at the installation site, and perhaps I'm sure many of those have been implemented by a lot of shops already. So use laser measures to increase the precision, so you have less amount for grinding and polishing tasks to be done at the field, and use some mock models and templates to ensure the installation process can be done without the need of on-site operation. If there's some small chance that you have to do some work at the site, consider performing them outdoors and use water, as we demonstrated earlier. Just simply use another water hose to provide additional water can help reduce the exposure. So this really comes a long way. NIOSH, we have conducted this research over the last 10 years. We conducted multiple field surveys as listed here, different surveys we published in journal articles, in government reports. And more recently, there was a Synergist article last October summarizing a lot of these same information presented today. In conclusion, the overexposure to RCS in this industry is really preventable by following all these verified control measures, following the hierarchy of controls. And engineering controls particularly, including those 2 control measures we discussed earlier today, can really help lower worker exposure to levels below the OSHA PEL level. So finally, I'd like to acknowledge all my colleagues who supported this research along the way. I do want to acknowledge that some of them are still on admin leave due to the pending reduction in force. So just want to acknowledge their effort in all this research. Of course, all of our publications are publicly available. If you don't have access to any of them for some reason, feel free to reach out to me. So I'm happy to share. With that, I conclude my part of the presentation. Thank you all.
Thank you so much, Dr. Chi. And I will send links to the presentations that you went over, which you went over a lot. So some of us will need to stop and digest everything and come back to it. I have lots of questions, but we're going to come back later on to ask the questions. So now I'm going to turn it over to Mark Mario. And he is going to provide an update on what the Natural Stone Institute is doing. So I'm going to let you take it away.
Thank you, Jenny, and thank you, Dr. Chi. I'm going to try to share my screen now. Everybody can see it. Yes, now? I hope.
It is coming along. There we go. We got it. We're good.
Very good. Okay. Let me make sure. So, yeah, and thanks to Dr. Chi for pointing out that engineering controls can be an effective method to reduce exposures for these shops. I happen to reside within the state of Georgia, so thanks for all you do in the state of Georgia, Jenny and team, for protecting the businesses here, me personally and all my local friends. But I do get the opportunity to visit shops all over the country on a regular basis. And since you mentioned California, these images here come from a shop down an alley in California. I've actually visited this. These aren't my images. These were from a CBS News story about California shutting down some smaller hand fab shops in a very specific area in Sun Valley, California, and LA area. But I've been in this area and there are multiple shops operating that used to look like this on a regular basis. This news article came out back in March of 2024. But the good news is, cup half full, is we also have shops like this. This is a shop in LA area that was complying with the 2024 California Emergency Temporary Standards, which are above and beyond what a lot of you in states like Georgia and outside of California are required. So they had to have strip curtains in place, demarcating the work area from regular, just a pedestrian traffic area. But this was an image we took during a tour we were providing to local health officials to show them what a compliant shop can and should look like, to contrast with those very dusty environments we looked at. And as I mentioned, I get to travel all around the country on a regular basis, visiting our members and non-members all over the country. And we have, hate to point it out, but our members are some of the best shops in the country. They're not the only shops, but more and more of them, like Dr. Chi has said, are involving these larger machines where they can do remote operation, get higher level of precision, a bit more output. But you'll notice one thing in these photos that I've taken. These are photos I've taken in shops. This is large production shops, one in Oregon, one in PA. You'll notice the floors are not just wetted, but you won't see large puddles of slurry. You may see little bits here and there, but you can see the raw concrete under there, the concrete floor itself. We joke around and say that shop's clean enough to eat off the floor, but it's not that I wouldn't eat off these floors, but you'll notice one thing in all these photos I'm sharing here that of good shops they're all wet processes. They're overall clean and organized. Even these high production shops, they'll have noticeable safety signage, STS books available and visible in the shop. Some of them may be requiring respirator use when they've been tested and require that if they're above action level. But it's not just the big high production shops. They are other members in other parts of North America. One in Ottawa on the right, and these are the guys doing the hand polishing, the finishing. Look at the floors again. They're still very, very clean and constantly wetted. And when we say wet shop, we don't just mean, water at the process, like Dr. Chi had pointed out. It's regular wash downs prove to be the most effective in keeping this. Wash these floors down, get the slurry, get the sediment into a collection system where it can be filtered out and away from the employees. I was glad Dr. Shi showed it because another item that we've had, these are more supplemental engineering controls over and above for our shops who are having their air monitoring, getting the testing done. If they get close to the action level or just close to the PEL and want to bring it down just a little bit, these are devices that aren't terribly expensive. Those filter walls that Dr. Chi showed can be a few tens of thousands of dollars. These devices, just a floor scrubber machine, you can get small ones, walk behind instead of the ride-on Zamboni style. And another one is this mobile HEPA air circulator that just uses HEPA filters and constantly removes those contaminants from the air on a regular basis. It can be used to bring those exposure levels down slightly. These tools alone aren't going to make a shop safe instantly, but if you're close to those exposure levels and want to just bring it down another notch, these are helpful devices to look at for your shops. Another thing I'd love to encourage all the fabricators out there to do to learn more about silica safety. Dr. Holroyd and her team have some great education they put together a couple years ago. We do as well. At the Natural Stone Institute, we have a silica and slab safety certificate training. It's currently about 5 hours of training. We're going to trim that down because some of it's a little redundant. But beginning next year, that'll be shortened, I think, to around 3.5 hours of training. But we cover the two primary safety topics that are specific to the stone industry. One is that silica safety we're all talking about right now. The other one is slab safety, slab handling, because unfortunately I hear about incidences where the slabs and handling incidences aren't just injuries. They're in many instances are fatalities. So people get killed handling slabs or mishandling slabs. So we coupled both of those training topics together in this certificate. I'd love to share a success that we have over 1,500 certificate completions since we rolled it out in November 2023. And we like to say that's affected over 10,000 workers in our industry with this safety training. All of our safety courses are available for free to anyone who creates an education profile and account in our NSI education system. You can see the website here and the QR code to get to all that. Also, all the silicon slab safety certificate courses, we had them fully translated a little over a year ago, so they're all available in native Spanish language as well. As Dr. Holroyd alluded to, we have been doing some of our own research from our fabricator members across the country, where the NSI and another association, ISFA, partnered with the Yale School of Medicine researchers to do some surveys and some air sampling studies of our members. You'll see this out publicly. We were hoping it would be out this month, but I think it's going to be out in another month or two in the American Journal of Industrial Medicine, Jenny and team. So you guys will look for it there. So I'm just going to give some highlight items, kind of tease you on this. But our study survey we conducted informational surveys, and we got survey results back from 257 participants just about their work habits, their practices. But we also got voluntary air sampling data from, I didn't write down here, see if I can see my notes here, over 47 from 47 states, I believe, but 42 shops in 24 states. So it's a large sample across the US, and then 4 from Canada. The overall conclusion that the main takeaways are not dissimilar from other studies, but that, like Dr. Chi pointed out, working with small hand tools presented the highest risk for RCS exposure. So those hand grinders, the polishers, the workers are within close proximity of the contaminants when those are used. And then dry work was the absolute worst. That had significantly higher RCX exposures. So wet isn't the be-all, end-all answer, but we want everybody at a minimum to start working wet with everything. Similar to a recent paper from Dr. Su and Holroyd that was published earlier this year, we also, in the Yale study, tried to identify similar exposure groups for specific work activities, wet or dry, activities grouped, like I said, large tools or large machine operators, and support services, and also what engineering controls were being used in addition to the materials. And as Dr. Chi also said, it's difficult in our industry because we know all of our member shops, they don't cut just one material, or they don't even cut just one material in a day. There's always a mixture of some natural, some artificial stones, some quartz, now some porcelain products, low silica, high silica. There's mixtures of materials being cut day in, day out. So it's going to be really challenged to identify a singular product thing in many of the shops that I visit. But the biggest conclusion was absolutely get rid of dry cutting if you can at all. And then prioritize those engineering controls where you invest the money, especially on the small hand tools, sheet wetting, strategies like that, to try and reduce those exposures to those workers. One thing we learned very early on in the collection of data with Yale was an overall lack of consistency among air sampling. You would think the certified industrial hygienists across the U.S. would all do things in a similar fashion, but whether it was individual CIHs, state agencies like consultation agencies, even across the U.S., all had varying levels of detail captured during these air sampling events, whether it was about products, specific activities, engineering controls, or PPE being used. We just didn't have full reports from all of these different air sampling events. So one of the things we created was to be helpful for our fabricator members, a guidance document for fabricators so they can better understand what that sampling process should look like, what information should they provide during one of those sampling events about the materials being processed that day, whether this is a normal procedure or something out of the norm. But we also created, rather Yale did, because they're more versed with the CIHs, guidance document for the sampling firm or consultant who performs that. So it'll have a lot more details into what we hope a sampling firm or consultant might gather during one of those sampling events. This would really help in the future in understanding the risk and the effectiveness of the available controls that are being used and are out there. I do want to point out on the right-hand side, this is just a quick screenshot. One of the resources we have available is our Silica education page there, www.naturalstoneinstitute.org/silica. We also have a general safety page as well. But we put our new resources in there, and we'll just keep adding to those as new resources are developed. I do want to say no one group's gonna solve this issue alone. It's not Dr. Chi. I wish you had the super brilliant idea to solve this solution tomorrow and make everybody safe. I wish I had that idea, but we don't. We're all going to have to work together to find a solution to keep these workers safe. More workers still needed to educate the fabricators and the workers about existing risks and best practices. More research is needed. Thanks for all the stuff you've done over the years and continue to do at NIOSH and agencies like that. More research is done to identify the primary source of the risk, whether it's activity-based or material-based or a combination. More work is needed from the medical community. Some of the problems in California and Australia were medical professionals not identifying this as a silicosis risk early on in the patients they were seeing. They misdiagnosed them, unfortunately, as some other COPD or some other lung issue. So more work's needed in the understanding of the medical community to better identify these cases early so that workers who do get sick get the proper treatment. And then more work is needed definitely from enforcement. The enforcement teams in the states and the regions around the world need to get out there and make sure that the employers, like those dusty, dirty shops we saw in those opening slides, that they're following the rules and complying with current standards out there. One of the things we can assure people with is one of the programs I lead. We have a credentialing program called accreditation, and all of our accredited shops have undergone voluntary safety audits from their state agencies. The other thing is on the right, the certificate of completion for all the individuals and workplaces who have completed that silicon slab safety certificate course. It's just another verification that the fabricators are doing all they can or trying to understand the risks and keep their workers safe. So what can fabricators do? Create your written silica safety program. If you don't have that in place, we have a bullet one of the available resources is a boilerplate silica exposure control plan. You can start there if you don't have one yet. You can work with a state agency like Georgia Tech, their state consultation, or in your state. They will help you develop a safety program, general overall safety, or a silica safety program. We do want fabricators to start getting their, or do you have air monitoring done? You can work all wet, but if you don't have air monitoring done, you don't know if there's still a risk in your shop. You have to have that air monitoring done to know if there is a risk or the extent of that risk in your facility. So get that air monitoring done. Have you had your employees medically evaluated? And when I say that, I don't mean just fit tested for a respirator and they're good. I mean, there's additional liabilities. Imagine when you hire a worker who has years of experience working at other shops, you may not know what the level of safety was at those shops. When they come to work at your facility, you're now assuming a healthy worker or possibly healthy worker. So we recommend that you have your employees medically evaluated, have a chest X-ray, chest CT scan with a B read, so they can see if there are any early symptoms of silicosis present in that worker. I know Concentra is one of the nationwide workman's comp or healthcare providers. There are other ones, but you want to have those employees medically evaluated so you have a baseline for where they're at, and then do that on a regular basis. You can also do things like lung function tests so you can see any degradation in lung function over the time while they work for you. And then what are the safety protocols? What engineering controls do you currently use? Are they the best available? Are they the newest? I heard Dr. Chi refer to some of them, and you guys are the wizards out there along with us. We look at different shops around the country as new technologies are developed or new strategies emerge. we want to share those as quickly and as early as possible to keep everybody safe, and make some of those are those larger machines. Some of them come with enclosures and doors to isolate the risk from the workers nearby, but sheet wetting, all those strategies, look into them and use the ones that'll fit within your shop. Before I leave, I do want to mention, since we did mention California, another possible avenue to control this would be through legislation. And SB 20 is proposed legislation in California to limit the sale of silica-bearing slab materials. One of the requirements would be for the shops, the fab shops would have to register. They would have to be involved in voluntary Cal OSHA compliance, certified training, which might look like something like our certificate, our training certificate, voluntary medical evaluation of all the employees, and formal registration with the state, would provide them a certification, almost like a licensure, to be able to purchase those silica-bearing materials. So that those slabs would only be sold to shops who are involved with known safe work practices. And then there's a component on the supplier also to make sure that they're only selling to those safe workplaces. So that's a strategy that's currently in process in California. I've got my fingers crossed. I'm really hopeful because there's a lot within industry that are backing this. They think it's a really smart way to control the product, and keep the at-risk product away from the unsafe shops. But we'll see how that goes in the next couple of months. With that, I'm going to wrap it up and turn it back over to you, Jenny.
Thank you, Mark. All right, so now I am a little bit biased because I work with Sean and Brandon, but Sean and Brandon are two amazing industrial hygienists that spend an exorbitant amount of time working in stone countertop fabrication shops, and really working with the small businesses and helping alleviate barriers to protecting workers. So without further delay, I'm going to turn it over to Sean and Brandon. And so we heard a very technical presentation from Dr. Chi. We heard Mark share the industry professional association perspective. And now Brandon and Sean are going to tell you what we see, what we hear from businesses, and how we're trying to help protect workers.
All right, good afternoon. My computer's on a little bit of a struggle bus, so if I crap out, just let me know, and Sean take over at that point in time. But my name is Brandon Philpott, and we are going to. Sorry about that.
If you go up to the display settings and hit swap, it'll switch it to up at the top of the screen.
Display. Oh. Oh, struggle bus on my part.
It's okay. Sean's going to take over and drive the struggle bus for you. It's light and fun in our office. So now you can just relax and speak, Brandon. So go take it away.
Yeah, so I'll do that. So over the next few minutes, we're just going to talk about what we actually see in the field. So as Jenny said in the beginning, the consultation program, we mostly service the medium to small businesses in the state of Georgia. So a lot of the shops that we go to are under 25 or less employees. So the next few slides just show you what we see in the field. You can go to the next slide, Sean. So typically, when we go to companies, these are the most common types of engineering controls that we see. So we see water-fed tools, as Dr. Chi showed earlier. We see the use of CNC machines in some shops. We see the use of a water jet in others, and then sometimes you have that water curtain that Dr. Chi also showed. But that water curtain is mostly seen in more of the larger to the other companies because that is a more expensive piece of equipment. All of the CNC, the water jet, all of those are expensive pieces of equipment, so we don't see them all the time in all shops. But especially the water curtain is probably one that we see the least amount of time. So the next few videos are just going to be of different engineering controls that we see, and you could play it, Sean. So as you see, this is just the use of a water fed tool, and you can see the amount of water that is being used in this process. And then as we go to a few of the later on in the presentation, we'll see the fact that with the water fed tools, the aspect of how housekeeping will kick in that manner. But as you see, this one is more of a center fed water fed tool. We can go to the next slide, Sean. And this is just another example of using a water fed tool. But one of the things that we want to really pay attention to, if you look at the respirator that the employee is wearing, you'll see that there is a buildup of dust on that respirator. So when we think about all the water that we're using a whole lot of water, and yes, it's capturing the dust particles, but what happens to those particles what happens when the water dries up? So you have situations like this where the dust will be left on the respirator or in other aspects of the shop that could potentially cause problems for the people that are not actually fabricating, but for the people who are working around those areas. So this is just the use of a CNC machine. And I said that the water is being distributed. And also these are the type of machines where we're able to, in a sense, we can set it and forget it. So the employee can just set what the cut should be, and then they don't have to directly stand there while the cut is being made. And we can go to the next slide, Sean. And then we have a water jet system. So it's just basically a really strong use of water to make the cut. So once again, we can set it with the computer system or the type of cut that we are able to want to make, and then allow the machine to do the job. And this just helps eliminate the amount of fabrication that needs to be done in later stages. So we're not having to make those cuts. The employees are not having to make those cuts themselves. They're able to just allow the machine to do the work, and then from there they may have to do some cleaning up, but the amount of time of working on that slab is a lot less than if they were just standing there and having to make the cut themselves. And then we also have a water curtain. So we don't have a pretty video of a water curtain like the other one. So the videos that you just saw are actual videos that were taken in the field. Some of them were a bit staged from when we were doing our Susan Harwood grant, where we did training where we created training modules for silica and silica exposure and working with in this industry. So that's where a lot of those videos came from, and some of the videos actually came from us just being on site and what we see day in and day out. But this is just the water curtain that Dr. Chi showed earlier, and as he said, it's just a use of is pulling the dust through and using the waterfall aspect in order to contain the dust particles. So this aspect is just really leading up to having good housekeeping. And as you see in the video, what they're doing is they are, as Mark said, it's important to make sure we are wetting down that floor. So right here, they're just wetting down the floor to move the dust that has settled or the sludge to those grates. And then from there, it will then go to their water recycling system. So the water recycling systems, they are just so important because, for one, with using so much water, we will probably have very high water bills if we're not trying to recycle that water. But so in the water recycling system, we're separating that dust from the water, and then we're able to reuse the water. But we want to just be careful about any of these engineering controls. We want to think about maintaining them. And with the water recycling system, if we don't have that system in place, we're not able to remove that dust. So once that dust dries, once the water dries, then all that dust will be left on the floor, which will cause additional hazard for maybe not the people who are doing the polishing or the grinding, but for those people who are standing around. And then, so the next few slides will show you when engineering controls are not in place. So this is the same employee that we saw earlier when he was using the water-fed system. So this is a staged photo or staged video. So we want to see how much dust is generated when we are not using, when we don't have that water-fed system. And as you see, the cloud of dust that is being produced from not polishing that long. So this is what you can see if you're not using that water-fed system, at least using that water-fed system. And so we want to make sure that when we're training employees to make sure that, for one, they know that no matter what, whenever they are doing any of those tasks, they have the water turned on, because you see that this is a water-fed tool, but he has the water turned off. So making sure that they understand that they should not be turning off the water at any point in time. And then, so we have the water curtain, and this is the actual photos from consultation visits of when those systems are not in place. So we have a water curtain in the back in the right picture, but you see if the water curtain was operating functionally, we wouldn't have all that built up dust on the actual machine. And as you see on the picture on the left, he has a water-fed tool, but the water is not turned on, and the amount of dust that is not only being emitted from the source, but how it's spreading to the walls and everything. So when we're thinking about making sure our employees understand that they need to properly use controls, we want to make sure that we are training them. If the tool is not being used properly and the water's not on, we don't need to be using the tool at that point in time. And then, so what happens when the water dries? So this is just another staged video of showing that when the water, we're having water everywhere, but we can have a dust problem. So this is just a random table in the shop where we use some compressed air, which we should not ever be using compressed air when we're working with silica. But you just see how much dust is built up on that machine. And they may do great housekeeping on the floor and removing the dust from the floor, but that dust also travels and it will land on other parts of the facility. So just want to make sure that your employees are really understanding that the water will dry up, and we need to make sure that we are cleaning down things so we don't have this buildup of dust. And also often I go to different companies, and we have the aspect of people using fans as a relief for the heat a lot of times in Georgia. So just want to be very careful about the use of fans. So you can see it's kind of a wet but kind of dry area. So we have a lot of slurry. So, but if we have that dried silica, the dried dust, all that fan is going to do is just blow it to a different area and then possibly impact another employee. So Sean to get more into about the paper that we recently published, but we saw that even the in different groups who were not actually doing any type of fabrication, that a lot of times that they were still exposed to silica above the action level, and even sometimes maybe the pill. So I just want to be just mindful about the people who are actually doing the fabricating, but also want to be mindful about the people who are not directly doing the fabricating. And so a couple of resources that you may want to review. Jenny, so if you look at the QR code, it will take you to the first paper, where it just talks about some of the engineering controls in Australia. And then Jenny earlier, she put the link in for the paper related to by Dr. Chi about the ventilation and engineering controls. But one of the quick things that I want to talk about, just the aspect of that controls are imperfect, and it may take the use of a couple of different controls to using 2 controls or more to help reduce that level. And then just want to really make sure you're maintaining those systems to make sure they're operating functionally. As Dr. Chi, he mentioned the fact that the airflow rate of, especially with that water curtain, to make sure enough air is being pulled away so we are effectively moving the dust away. And then we want to make sure that we're using the appropriate amount of water to suppress some of those the particles. We want to think about what type of work are we doing, what type of work is being done at that point in time, and just make sure that we're staying on top of our housekeeping to make sure that we are continuing to try to have that shop wet, and we are using a squeegee or using some type of scrubber to help remove some of that sludge and slurry to help remove. So when the water does dry, we don't have as much dust or settled dust present in the facility. And that'll be it for me, and Sean will take over.
Hey, good afternoon, everyone, or good morning, or good night from wherever you're from. Thank you for joining us today. My name is Sean Castillo, and I'm a CIH over at Georgia Tech. So I'm with Jenny and Brandon's team. And as part of our consultation, we are going out to sites to do this.
Sean, I'm going to jump in real quickly. If you could just lean in a little bit more, the microphone in the office where you are isn't picking you up as well. But when you lean in and look at the computer, we can hear you great.
Can you hear me like this?
Perfect. Thank you.
All right. So my name is Sean Castillo. I'm a CIH over at Georgia Tech. So I've been here since 2018, and a lot of our work has been going out to these small fabrication shops, or medium-sized too, to do silica monitoring. So I want to talk about our paper a little bit. The sake of this work group isn't to get into the weeds, so we will share the link so you can review it. But we do want to talk about some of the trends that we've seen. And again, I just want to highlight everything that we've said so far about these engineering controls. They are only as good as the maintenance and the training. And so we've been to a lot of facilities where employees will get a dust collection system or some kind of polisher. Many times they don't speak English, and management might only speak English, and they're given a tool and they say, go to work. And if they don't get the proper training, they don't know that there's bags that are supposed to be disposed of. They don't know that they're supposed to do inspections of water hoses. And then a lot of times manufacturers or employers, I guess I should say, might not do the same preventative maintenance that we need to make sure of. So if you're going to spend money on these kind of tools, because they aren't cheap, we want to make sure that we're using them accordingly and that everyone understands how to do it. So a little bit of our paper, we actually published pretty recently. This was in conjunction with ourselves on this call, Haley Warren and Dr. Juicharm Su over at Georgia Southern University. And it was to go into some of our findings at our fabrication sites here in Georgia. So it was through consultation services, and we are limited to what we can do in our home state. And so what we did, it was a period between 2017 and 2023. We have gone more since, and we've done some more before. However, we visited approximately 11 companies. We did about 17 sampling visits. We monitored about 77 employees and 75 full shift employees. We're looking at crystalline silica and respirable dust. You know, most of your standard sampling, you're doing both in your analysis. And we compared our exposures to the Pell, which has been mentioned, and the action level. As the OSHA consultation program, we are looking and relating to OSHA compliance, at least on the federal level, since we are in Georgia. And so a couple quick things about our results. So for around 63 employees who exclusively use wet methods, so we do generally see a good amount of wet methods in these small fabrication shops. We saw that 51% had exposures at or above the Pell, reaching as high as 370 micrograms per meter cubed. And about 70% of all of the exposures were above the action level of 25. Meaning, if they're over that for 30 or more days a year, they have to do medical surveillance. You have to have a silica exposure control plan. And so a lot of that standard does come in at that level. We also saw that there are differences, but we were having overexposures from small and large fabricators. And for us, our larger fabricators are over 25 or more. The scope of consultation usually goes to about 250. We do some limited service with larger ones. But with our small fabricators, we worked with about 6 companies, we conducted 8 visits, monitored 28 employees. And we saw a difference of exposure ranges from 9.2 to 370, about 50% over the Pell, 75% over the AL, or the action level. And for those large fabricators, we're about 5 companies, 9 visits, so almost pretty one-to-one. Monitored 49 employees, so we did have much larger employees just due to the amount on site. And our exposure ranged from non-detect to 5,100 micrograms per meter cubed. And those large exposures are dry exposure, so I'm going to talk about that very briefly too. But about 55% over the Pell, meaning respiratory protection is required, and 71% over the AL, where we have to do medical surveillance, possible sampling depending on how you're going about the OSHA standard, and the actual X-ray tests. So one thing I wanted to note, again, we're not getting deep into our paper for the sake of this. We could talk for a long time, and if anyone wants to reach out, please reach out to us. We'd be happy to discuss it with you. I just wanted to highlight one company specifically and talk about the importance of everything we've discussed today with engineering controls. And so if we go to company 6, this is a company that we have gone to over the years a few times now, and we have seen changes in how they're working. And so, as Brandon alluded to, this is that company who had that water curtain. First time we went out there, they had their water curtain, but it was not actively in use, and they were doing all kinds of dry fabrication in a back room. And so they were outside, they had some general ventilation, which is better than not. However, there were no wet tools and there was no local exhaust ventilation, and we were seeing heavy overexposures. So that was our site 6A. We went back out again, that is our 6B site, and we saw that those exposures for respirable crystalline silica then went from 15 to 2,000 on site to 16 to 230. And I will tell you that 2,000 and that 230 are both for the fabrication tasks in that same area. And so there was still an overexposure for that site, but at least we saw just how much that exposure could be reduced when they were properly using their wet tools, right? And then later on, again, it's important to know that when management changes, when employees change, when there's turnover, we went back out there a couple years later, did some sampling, and they were doing everything in that room dry again. And they had multiple employees in there doing all kinds of dry fabrication. And so we saw very large overexposures, very above the Pell. Next time we went back out, we saw a reduce. However, this is important in why we take our sampling notes. Because they did some things a little differently. They did add water, but it is important that we are taking our site notes to understand and get a full story of that site. So again, we can discuss these results a little more. I will leave the QR code to this study, but I just wanted to show you the differences that go when you have a functioning system that isn't in place, and then you decide to use it, and then lapses happen, and later on down the road, it gets cut to the curb. And then you have those overexposures again. So we want to be consistent with our preventative maintenance and our training of everyone to make sure that we are doing what we need to do. This is the QR code. I'm going to talk very briefly about consultation again and some of our resources, but this will be in the notes that Jenny sends out. But if you want to take a quick note of this right now, you can do so by QR code. Now with our consultation program, we have mentioned this already, but we are a free service to what we call smaller businesses, which is around 250 or less employees. We cover them at Georgia Tech in the state of Georgia. However, there is a consultation office in every state. Jenny did link that in the comments earlier where you can find your state and who is your specific organization. And what we are is we are a free confidential resource that goes out and does silica monitoring or any other kind of industrial hygiene monitoring. The essence of what we do is we go out and we do on-site OSHA consultations. It is a free service. However, companies do have to agree to correct serious hazards. So we will not cite you monetarily. However, we will tell you any standards that you are in violation of, and we do require documentation that those are correct. Now, we do offer full service where we do walkthroughs, program reviews, and the main thing that at least our team does is that industrial hygiene monitoring. And so Mark alluded to it, Dr. Chi alluded to it, Jenny alluded to it, Brandon as well, but industrial hygiene monitoring can be expensive because you are paying for the time, you're paying for the media. And so these consultation programs are a great resource for you to use where you can get that information for free. And you can check to see where your engineering controls are stacking up with personal exposures. And so I'll leave these for you to read. We do offer other services besides safety, health, and safety and health management development, but we do have all of these resources. We offer resources on our page. So we have our trainings, we have all of our guides. OSHA has some really great guides for silica. Their small entity compliance guides will show you the silica control plans and their templates, as well as what Mark mentioned with the National Stone Institute with their exposure control plans, other sampling plans as well. So the resources are out there for your use. So whether it's from us, National Stone, Silica Safe, OSHA, or other resources, please at least spread that awareness so we can start getting people aware to what silicosis can do and how it can change someone's life. But you do have help out there, whether it's from us or your industry partners. And the last thing I wanted to mention, if you do go through the paper, the way we usually look at these kind of things, especially with exposure groups and how we know that polishers are usually going to have higher exposures. We all talked about handheld tools. You know, we do have some of those higher exposures than a CNC machine. We don't want that to be the end all be all, however, because a lot of these small facilities that we go to, especially here in Georgia, oftentimes your CNC machine might be right next to your grinder, your polisher. You might have support workers on a forklift or who are doing other manual handling, but then they're standing next to a polisher. So it's not always just dependent on the task. It also depends on your vicinity when we're looking at all of those exposures. And so here is our OSHA request assistance. So it is that free program again. I do implore you, if you are in Georgia, to look at us, and if you're in another state, to go to your actual consultation program. And then we have additional resources, which I'll let you read in the slides. But I will hand that over to Jenny since I'm over time a little bit.
Completely fine. All right, I'm going to stop recording and then we're going to dive into the conversation portion.